I found some chips and some tangerines.
I found some butter tarts and a beautiful looking steak.
Do we have to heat that up?
No, it's beautiful as it is. I like it blue.
You know what this reminds me of?
What does it remind you of?
Anna's calculus class.
Really? That's weird.
Yeah? You don't see it?
Actually, I am starting to see it a little bit. I'm starting to see that if I were to take this tangerine and I were to throw it up and it comes back down, it's almost like it's a vector. Because as it's coming down, it has both direction and magnitude.
But don't forget, the direction stays the same, but the magnitude changes because the speed increases as it's falling.
That's a good point, Emil. I forgot that one.
But vectors don't always apply to just moving objects. There's a vector between these two tangerines too.
What?
And they're not moving because you have a distance.
Oh, that's true. If you were to take this tangerine and you were to look at the slope at a given point, it's constantly changing. If you were to change where it is.
You mean like a tangent?
It is almost like a tangent.
It's a tangentarine.
The tangent of the tangerine.
Kind of looking at these Ruffles chips. It's kind of almost like a parabola, a hyperbola. You know, I read about something. Do you know what it's called? It's like a...
Is it a parabolic hyperbola, maybe?
Parabolic hyperbola, yeah.
Is that what they're called?
Yeah. It's like a plane, and you can see it has like a little sine wave on the side.
Oh, that's true. It's almost... Yeah. Wow, that's amazing. There are examples of this math all around us, even when we're eating this dinner that I had no idea there would be anything involved in it. We can see that actually on this surface, if we look at it as a plane, we can see that we have almost a design, almost like a sine wave going on here.
Oh yeah.
Do you see that too, Emil?
Yeah, it looks like a sine wave on the y-axis.
Yeah.
And a cosine on the x-axis.
Oh my goodness, it does. That's amazing.
That's incredible.
It's a beautiful looking steak.
You know what?
What?
You know what the derivative of a cow is? The derivative of a cow is?
The derivative of a cow? How am I supposed to calculate the derivative of a cow, Emil?
It's prime rib.
Oh, prime rib. How about a game?
Sure, how about a game of checkers?
Checkers? I love checkers. Oh, here's a nice checkers board.
Imagine that.
Just happened to be sitting there. You know what I do see, Emil?
What do you see?
I can see that we can actually have a vector between these two checkers pieces because it has a direction.
Oh, so the components would be 3 right and 1 up.
Exactly.
Well, it's also a plane. We could say that these are points on a plane, and we would only need 3 points to define a plane.
Oh my goodness, you're right. Because it then has 2 direction vectors, right?
Want another butter tart? Last one left.
No thank you. I'm just so full. Full of knowledge. Knowledge from Anna's math class.